In this problem, we need to solve a simple trigonometric equation. Cotangent equals sine. And so, of course, we recall that by definition, cotangent is cosine divided by sine. So on the left, we have cosine t over sine t. That is the very definition of cotangent. And before we multiply left and right by sine t, we have to make sure that sine is not zero. Because if you simply say that this is equivalent to cosine t equals sine squared t, which you obtain by multiplying left and right by sine t, that would be wrong. Because in particular, nothing prevents in this equality sine to be zero. So we have to make sure that we can go back from this to this, right? Remember, this arrow means that you can go in either direction. Definitely, I agree with this. But I don't agree with that direction. To go in that direction, you have to be able to divide by sine. To be able to divide by sine, you need to ensure that sine is not zero. Now, of course, you replace sine squared by 1 minus cosine squared. That's just Pythagorean identity. Sine squared plus cosine squared equals 1. Now we move cosine squared to the other side, or rather cosine t moved to the other side, doesn't matter. So we get a quadratic equation in terms of cosine. Cosine squared plus cosine t minus 1 equals 0. Sine t is not 0. Now we use a quadratic formula. So this here again is a quadratic equation in terms of cosine t. So when we apply the quadratic formula, the formula by which we find the roots of quadratic equations, we get that cosine t equals -1 plus minus 1 squared minus 4 times 1 times -1 over 2. Sine t is not 0. Now, that means that either cosine t equals -1 minus, the expression under the square root is 5, -1 minus root 5 over 2, and sine t is not 0. Or that cosine t equals -1 plus root 5 over 2, and sine t is not 0. But we quickly realize that -1 minus root 5 over 2 is less than -1. That's easy to check. -1 minus root 5 over 2 versus -1. So multiply by 2, we get -1 minus root 5 versus -2. Move -5 to the right and -2 to the left. We get 2 minus 1, that's 1, versus root 5. Of course, 1 is less than root 5 because if you square this, you get 1 versus 5. So we get less, 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 and less. And therefore, this particular system is inconsistent. Cosine cannot be less than -1. So we get that cosine t equals -1 plus root 5 over 2, and that sine t is not 0. Well, that sine t is not 0 simply means that t is not pi times n when n is an integer. And again, why is that? That easily follows if you recall the unit circle, and that sine equals 0 at 2 points on the unit circle. Here and here. Sine t equals 0 if and only if t equals an integer multiple of pi times n. So because we want sine t to be not 0, we write that t is not pi times n, and cosine being root 5 minus 1 over 2, that's also 2 points on the unit circle. And if you remember how we solve equations cosine t equals constant, cosine t equals -1 plus root 5 over 2, which is, by the way, clearly is a positive number. Because root 5 is more than 1. But on the other hand, it's less than 2. That's also easy to understand if you compare -1 plus root 5 over 2 versus 1. Multiplying by 2, you get -1 plus root 5 versus 2. Moving -1 to the other side, you get root 5 versus 3. Squaring up, you get 5 versus 9. And of course, 5 is less than 9. So we do get that this number is less than 1. So solutions exist. And the equation cosine t equals root 5 minus 1 over 2 is equivalent to t being plus minus arc cosine of root 5 minus 1 over 2 plus an integer multiple of 2 pi. So these are 2 points on the unit circle, this one and this one. This one is arc cosine, this one is negative arc cosine, and from either of these 2 points, we can make any number of full revolutions. Of course, these 2 points are different from these 2. So whenever cosine t equals root 5 minus 1 over 2, this condition that sine being on 0 is automatically satisfied. And this is our final answer. This problem is now over.